Okay, so now we're on page 38. Okay, and we're talking about now rational exponents. We've previously been talking about real exponents, integer exponents. Okay, so our rational exponents are exponents that are a ratio, and therefore they can be written as a fraction. Right? This definition's a little unclear, so let me rewrite it. That is, if I have x raised to some fraction power, m over n, that is a rational exponent, okay? Then there's a couple of different ways that we can write that to help in our simplification. The important thing to note is that the denominator will become the root, and the numerator will stay as a power. Why this is going to be helpful for us, this is written in the rational exponent form, but sometimes what we'd like to be able to do is write it in radical form. So x to the m over the n can be written as a radical of any root. Okay? So the nth root. So for example, if this is a 2, we would be taking a square root. And then we have a freedom to first simplify that root and then raise it to a power, or perhaps sometimes it might be easier to first raise the base to the power and then take the root. So let's do some examples of this. Number 1, we have 16 to the 1/2 power. Remembering, this will be our root, and this will be the power. Our base is 16. So, using our first rule, this is 16 to the square root, and you don't have to write the 2, but you can. And then I can raise that to the first power, or I can take 16, in this case raise it to the power first, and then take the square root. Okay. Notice if I don't write the 2, the 2 is understood. Alright, so first I take the square root of 16, and the square root of 16 is 4, and we leave that to the first power, which is just equal to 4. Or I could come over here, leave the square root alone, take 16 to the first power, which is just 16, and then simplify to get 4. Either way, we'll come up with the same answer. Let's do another example. So 2. Our base is 27, and we're raising that to the 2/3 power. The root we were taking will be a third root. Okay? So, what I might do, I think I'm inclined to take the cube root of 27 first. Because 27 is a perfect cube, and then raise it to the power 2. Now, just to illustrate that 27 is a perfect cube, this is the cube root of 3 times 3 is 9, times 3 is 27. Up top, we knew that the square root of 16 was 4 because the square root of 16 could be written as the square root of 4 times 4. So, therefore, we had a group of 4s, and the square root of 16 is 4. Now, when we're working with a cube root, we're not looking for a group of 2, we're looking for a group of 3. And here I have a group of 3 3s, which means then, well, this quantity is still squared, that the cube root of 27 is 3. And we still have to square that quantity, which then equals 9. Let's do another. 25 to the 3 halves power. Again, the root we will be taking is the denominator. Okay. So this is equal to the square root of 25. And then, since the square root of 25 is a perfect square, I'll take that first before raising it to the 3rd power. We know that the square root of 25 is 5. And that is still cubed. We know that because 25 is 5 times 5. Okay. And 5 cubed then is equal to 125. So 5 times 5 is 25 times 5. Okay, to cube it. 5 times 5 is 25. Carry the 2. 5 times 2 is 10. Plus 2 is 12. Four. 8 to the negative 2/3. Okay. So fractions can, our fractional exponents can also be negative. So what I would like to do in this case is get rid of this negative exponent and make it positive. Okay. We do that by thinking about this as over 1 and dropping it below the division bar. We need to have a 1 as a placeholder, and this becomes 8 to the 2/3 power. Again, the denominators are root. So this is equal to 1 over 8. But I'm going to take the cube root of that. And since 8 is a perfect cube, I will do that before I'll square it. Okay. So this is equal to 1 over the cube root of 8 is 2. 8 is 2 times 2 times 2. So I have a group of 3 2's. Therefore, the cube root of 8 is 2. Okay. And I still have to square that. Now, I can finish the problem, and 2 squared is 4. So 8 to the negative 2/3 power is the same thing as positive 1/4. Okay, let's make it a little more complicated. In number 5, we have the quantity 4 over 9, and we're going to raise that to the negative 1/2 power. Okay. Again, my personal preference is to get rid of the negative exponents. Okay. So to do that, we'll use the rule that says I can take the reciprocal of what's inside, and now the exponent will be positive. I have a quotient to a power. So let's remember the rule that says, well, that's the same thing as the numerator to the power divided by the denominator to that power. And now we can change our fractional exponents, our rational exponents. Remember, these are the roots, so we'll be taking the square roots. So this will be the same thing as the square root of 9, and this will be the same thing as the square root of 4. And these are to the first power, if you want to think about it that way. Alright, and now we can simplify this. The square root of 9 is 3, still to the first power, divided by the square root of 4 is 2, still to the first power, but anything to the first power is just itself. Okay. In number 6, we're going to multiply with like bases, so it'll hold true with fractions. X to the 2/3 times x to the 5/6. So here we are multiplying with like bases, so we need to add the exponents. This is step 1. Now all of this is in the exponent, and we would like to simplify that. So to simplify this exponent, we're going to have to add fractions, and when adding or subtracting fractions, we need a common denominator. In this case, it will be 6, so I can multiply this by 2 and this by 2. So this is equal to x to the 4/6. We didn't have to change the 5/6. Oops, I'm sorry, 5, sorry. And then in the end, when we add these, it becomes 5/6 plus 4/6 is 9/6. However, 9/6 is not a simplified fraction. We can simplify that. 3 goes into 6 2 times, and 3 goes into 9 3 times. So this is the same thing as the x to the 3/2 power. Which we could write as x to the square root, or x cubed square root. I don't really see an advantage in this point. This is a little more complicated than here. Up at 9, 9 to the 1/2 could be simplified, so that's why we moved forward with it. And number 7. In this case, we're dividing with like exponents. So this is x to the 3/4. We'll divide that by x to the 1/2. I'm sorry, we're dividing with like bases. Okay, so here's our division. Here's our like base. Right? So when we're dividing with like bases, we're going to subtract the exponents. Okay, so we have 3/4, subtracting by the rule, and then 1/2 from here. Again, we're in the predicament of having fractions in the exponents that we need to simplify, but that's alright. We'll just get a common denominator. Multiply this by 2 and this by 2. So we'll get x to the 3/4 minus 2/4, which is equal to x to the 1/4 power. which we could write as the fourth root of x. Either of these are acceptable. They are equivalent answers.